Hey A&Pers, this is Dr. Jones checking in. This is A&P 1 lecture test for video 8, covering page 9. So we're talking about excitation-contraction coupling. And excitation-contraction coupling is the link between the muscle action potential in the sarcolemma and the muscle contraction. And this happens at the triad. So we are here. I move my face out of the way. All right, so on reaching a triad, I did put a recording sign on the door. I made a new one with all of my colors of sparkles. So on reaching the triad, and as you recall, a triad is a T-tubule with two terminal cisternae, one on either side. On reaching the triad, the muscle action potential, which we see here as a red lightning bolt, this is the muscle action potential. Okay, as the red lightning bolt, muscle action potential triggers the release of calcium ions from the terminal cisternae of the sarcoplasmic reticulum. You recall that the sarcoplasmic reticulum is the lacy sweater sleeve that specialized sarcoplasmic reticulum that stores a boatload of calcium. And it has voltage-gated calcium ion channels. And this muscle action potential is a change in voltage. It is an electrical activity. And so when this change in voltage reaches the membrane of the terminal cisternae, which is the two ends of the sarcoplasmic reticulum, that opens those calcium ion channels and calcium is released. So let's make sure we've got all the words for the note set. On reaching a triad, a muscle action potential triggers the release of calcium ions from the terminal cisternae of the sarcoplasmic reticulum. This dramatically raises the calcium ion. You can go plus plus or 2 plus. Ion concentration in the sarcoplasm. So here's a question. At rest, is there more calcium in the sarcoplasmic reticulum, or is there more calcium in the sarcoplasm? In the sarcoplasmic reticulum, yeah. The book said, I think, like 40,000 times more calcium in the sarcoplasmic reticulum than in the sarcoplasm. So at rest, there's definitely more in the SR, the sarcoplasmic reticulum, than in the cell, the cytoplasm, and of course the cytoplasm of a muscle cell is sarcoplasm because it's special, so it gets a special name. Okay. So now we're releasing, because of the muscle action potential and the voltage-gated ion channels in the terminal cisternae, we are releasing calcium into the sarcoplasm of the muscle cell. Because, here we go, the terminal cisternaes are located at the zoos. Recall there's a triad surrounding every zone of overlap. So the terminal cisternae are around each zone of overlap. Because the terminal cisternae are located at the zone of overlap where the thick and thin filaments interact, the effects of the calcium release on the sarcomere is instantaneous. So it's instant, it happens all at once. Next page. Okay, calcium is the lock that keeps the active sites covered by tropomyosin. I'm sorry, the lock is the troponin. Calcium is the key. Troponin. There we go, troponin is the lock that keeps, and here's a picture of the troponin holding the tropomyosin on the active site on actin. Okay. So when calcium binds to the troponin, it changes the shape of the troponin and it moves it out of the way into these little indents, little V's, and it moves it off of the active sites on actin. Which terms were we looking for the note sets? Troponin is the lock that keeps the active site covered. Calcium is the key to the lock. When the calcium binds to troponin, it changes shape and position, rolling the attached tropomyosin away from the active site on actin. With this change, the contraction cycle begins. So when the myosin binds to the active site, the binding is called cross-bridge formation. Okay. All right. So how does this work? Let's do an overview of everything we've said in the last 2 pages. Okay, so first, number 1, we have neural control. The skeletal muscles only contract when the nerve tells them to. Excitation is the action potential, releases acetylcholine into the synaptic cleft, which causes a muscle action potential. So we've had an electrical activity, a chemical activity, which causes another electrical activity, which is about to cause another chemical activity, at least a release of calcium. And that's number 3, the release of the calcium ions from the SR into the from the sarcoplasmic reticulum into the sarcoplasm. They bind. And then 4, the contraction cycle begins when the calcium binds to troponin, pulling tropomyosin off of the active site on actin and allowing the myosin head to bind. And that causes the sarcomere to shorten, number 5, which generates muscle tension, which is number 6. So that's kind of an overview of everything we've said. Oh, add the number 6. There didn't used to be a number 6. They changed it, and I forgot to type it in. So there you go. So this has been ANP1 Lecture Test 4. That was page 9, so it was video 8. Thank you, as always, for tuning in. The education must go on. Dr. J.